Ready. Ready. Ready.
Hello, welcome to Enlightning. I'm so glad you're with us today. Thanks for joining. Today we're going to learn about Inspector Gadget from Qasim. Qasim, hello, thanks for being here. Introduce yourself, please.
Hello, it's great to be here. I am Qasim. I'm currently working as a software engineer at Microsoft. I'm one of the maintainers for the project we're going to talk about, Inspector Gadget. And other than that, I like to contribute to different open source projects.
Amazing. What other ones do you like?
I think since I work mainly in the containers and Kubernetes ecosystem, so everything related to that. So for example, it could be containerd or other than around in the similar space.
You're a passionate fellow. You do it for your day job and your hobby. That's pretty cool. We have Maya here with us in chat. Hi Maya, thanks for being here, friend. And if you are here, please do say hi and say where you're visiting from. I think this is so cool that we're a part of a global community. I'm here. I'm in Austin, Texas. Where are you, Qasim?
I'm based out of Hamburg, Germany.
Right on. Cool. Okay, let's dig right in on the technical stuff. So, help me understand Inspector Gadget by first talk about what problem it's solving. What was the world like before Inspector Gadget that caused it to get created?
Okay, perfect. I think I would start off with there was a big gap between all the low-level data collected by different debugging and troubleshooting tools and how it relates to Kubernetes containers and pods. Right? So it's great that you can collect low-level data, but the real power really comes if you can see how it relates to Kubernetes containers and pods, and that what's make the data more powerful.
So low-level data like kernel.
Yes.
What's a couple examples? Okay, low-level data and Kubernetes containers and pods.
Yes. It could be as like you run TCP dump and you see really the network packets, and you have no idea how that low-level data translates to Kubernetes containers and pods. So something like that.
We have Ganatak here. Hello, Ganatak. How from France? Oh, I didn't know that about you. So how recently was Inspector Gadget created?
It was created in 2019.
Okay. And so, okay, it's been around a hot minute.
Yeah. And I would say that other than that, the other issues that we were trying to tackle was if you wanted to do performant observability, you needed to use technologies like eBPF, which are really like, but there wasn't any package manager or any orchestrator to do it across your Kubernetes clusters.
eBPF
Yes.
had potential for performance observability.
Yes. But there wasn't any package manager, I would say, or an orchestrator for it.
a package manager or an orchestrator for eBPF.
Yeah.
I think instead of writing, we don't have that, I have a feeling we're about to have that. So I'm going to wait until. So great. So we have eBPF has great potential, but it hasn't been realized yet. And then we can get this low level data, but then we don't know at all how it's relating to the higher level constructs, especially Kubernetes containers.
Yes, exactly. Yeah.
All right. And now our hero, the hero of today's story, Inspektor Gadget. So what is Inspektor Gadget?
Okay, great. I think to define it, we can say it's a set of tools. We call them gadgets, and a framework for data collection and system inspection.
And a framework?
For data collection and system inspection on Kubernetes and Linux host.
And this system inspection and data collection is at the kernel level?
Yes.
On Kubernetes
and Linux host
Linux.
Using eBPF.
Nice. Cool. So what I know about eBPF, I've covered Cilium. I've covered a few technologies. I covered Pixie. Pixie seems kind of related to what you're doing here. And what I understand from eBPF is that you can view and inspect things that are happening at the Linux kernel. QBarm is another eBPF project we covered, without sacrificing security or performance. Is that a good definition of eBPF, or is there more I need to understand about it?
I think we can build on top of that. Like it's mainly we have these hooks that we can attach certain programs to and collect the observability data. I think.
Okay. Oh, okay. Is that okay? So I have eBPF. I'm thinking about hooks and observability data, and I'm also thinking still about package management and orchestration, which I can't guess at how that is related.
I think once we talk about the core concept, like once we dissect the idea of a gadget, that would naturally come in.
Okay, great. So do you think on the board we should write a quick definition of eBPF or?
I think we can do that. Yeah, of course. So I would define eBPF as this a virtual machine in a kernel that allows you to run eBPF programs in a secure and efficient way.
Can I say a sandboxed VM?
Yes.
Sometimes I surprise myself that I know things. Sandbox VM in the Linux kernel. I never thought of it as a VM before. This is a very helpful. That does what?
It allows you to kind of run these eBPF programs, which attach to specific hooks and expose the data, observability data.
Allows you
to connect to specific hooks.
Yeah, I'm wondering if we want that level of I'm wondering whether to make it a little more simple or whether we want. So allows you to attach to hooks. What does that mean?
Like for example, if I want to see a file is being open or a DNS request is being happening, so I can attach to those kind of events happening in the kernel and get the observability data. I would say like opening of a file.
And
Or
then
yeah,
a file being opened and then do something, or is it always observability data?
you could do more, but you can do more with it, especially in the network domain. But I would say then you can observe it. And for our use case, right now, we only kind of observe it.
Observe, manipulate. It can be manipulate.
Yes.
Okay. How's this collaborative definition? eBPF is a sandbox VM in the Linux kernel that allows you to attach to hooks, for example, a file being opened, and do something like observe or manipulate.
Yeah, sounds great.
Awesome. Good job. Go team. So now it sounds like the next thing to talk about is what is a gadget?
Yes, exactly.
A gadget is
A gadget is an OCI image,
okay.
which is composed of different layers.
Uh-huh.
And that would include eBPF programs.
Plural?
Yes.
Okay.
And there's a metadata to it. So they're like this for, maybe we can draw the picture of it. Maybe there's like four
Okay.
of the different components in it. I would say, so it's like we have eBPF programs, we have a metadata file.
Can we finish the definition and then I'll draw a picture because then I'll know how much space I have.
So I would define it as it's an OCI image composed of different layers. And these layers are what we're going to talk about in detail in a bit. But
with what goal?
the goal is that you can run them for your use case and then collect observability data. So they live in these like Docker containers in OCI registries. Like that, you can pull them, run them, and then they will do something for you, like monitor if a file is being opened or some DNS requests are happening, stuff like that.
They do observability things?
Yes.
This is that do writing that do observability things.
I think maybe we can like polish them once we build up.
I like it. Cool. And so now we have a gadget. This is our, let's switch colors. I tend to write mostly in green and orange because they show up the best. Okay, so our gadget has layers. Does it matter? Is there an order to the layers?
Not really. There is one like which is mandatory right now, which is like this layer of eBPF programs.
Okay.
That's like a mandatory layer right now, which you want to bake into your gadget. Then you have a metadata file.
Okay.
And then you have a WASM program.
Ooh, you're hitting all the buzzwords. WASM program. Okay.
And then we have this layer of BTF gen.
BTF
gen.
I have no idea what that is. But that's why we're here. or not. Or you could say that part's not important.
Yeah.
That's fine with me too.
I think in terms of these different layers, I would say like the eBPF programs are the one we just talked about.
Okay.
The metadata file includes any information about gadget name, where the source code is, and also once you run a gadget, how to control its output and stuff like that. So that kind of lives in metadata.
Okay. This is mandatory.
Yes.
And what lives in metadata?
Name of the gadget, description,
Okay.
and there are other knobs via which we control how the gadget should output stuff and stuff like that.
Okay. Okay. What else do you want to say more? I guess we should maybe.
Yeah, I think we can say something about like to kind of maybe briefly talk about like these gadgets. They actually collect data using eBPF, and then you can process that data using WASM. So that this WASM program is optional, but it's there to help you to process the data further. To explain on that, for example, with eBPF, I collect, I kind of see a network packet and I want to see what's in there. For example, we have this gadget called trace DNS, which allows you to see DNS packets. And then you will collect them using eBPF, and then you will process them using WASM. So that's kind of this. That's why this layer is optional. If you need post-processing to your observability data, then you will need a WASM program.
I have so Inspector Gadget is a set of tools. So does Inspector Gadget have a bunch of gadgets out of the box, or is it
Yes.
provide you the framework to build a bunch of gadgets? It has it already.
Yeah, I think, yeah. So I think what we are right now is we are a framework, and yet we also have certain use cases we already feel like, and we provide gadgets for that.
Okay.
So that's why in the definition, we are a set of tools. Like we also provide you gadgets, which are officially, we build them, we maintain them.
Okay.
And then we also are a framework which allows you to build your own.
Cool. So I have two questions right now. One is what's the BTF gen, and do we want to talk about it?
I can
Is
just
it a
say that
can of worms? Okay.
it's just for the portability of eBPF programs.
Okay.
So portability is a challenge for eBPF, and it's on certain systems. If we don't have the BTF information, we use this layer for the portability of our programs.
Excellent. And then question 2, and I don't know if this is board worthy, but like, to help me form my mental model, can you give me some examples of gadgets that the Inspector Gadget project maintains?
Yes, I think that's a great one. I think we can start off with trace DNS. Trace DNS.
Yeah, I'm thinking about board stuff. Okay, so we're gonna get into these. For my mental model, will you just rattle off a few so I can kind of get in the zone of what a gadget is a little better? Trace DNS sounds like tracing.
Yes. So we have these gadgets which can trace events as they happen. So that would be like, for example, a trace DNS, tracing if the files are being opened, stuff like that. And then we have this gadget called snapshot process, which allows you to see processes in a specific container. So imagine there's a tool called PS, which allows you to see processes on a Linux host, but you can see it across your entire Kubernetes nodes, pods. Similarly, we have gadgets for profiling. We call them profile block IO, which allows you to profile block IO of Kubernetes nodes.
Cool. Okay, this is helpful. So, how many gadgets does Inspector Gadget maintain? Roughly.
I think it would be around, I would say around 15. That's just a number that I can think of, but around 15, I think.
Okay. And also provides...
We'll talk a bit. I think maybe what helps is we have a way to discover them. So maybe that helps. That's why we'll talk a bit about that as well.
Cool. Inspector Gadget maintains about 15 gadgets and also provides a framework to build your own.
Yes.
That helps me. And so now let's talk about the gadgets. Except before we do, let me think through this idea that we're doing eBPF program orchestration
Yes.
with gadgets, package management and orchestration and with gadgets. So a gadget you deploy on a node and then it's acting at the kernel level. And then gadgets must be networked in such a way that they can talk to other gadgets on other nodes. Is that correct?
No, it would be more like there would be a client, like we have this CLI interface,
Okay.
which you actually run,
That makes sense. Yeah.
and that it'll talk to all the Inspector Gadget pods running as a daemon set on different nodes, and everything like all the observability data would then from there send to you.
So do you want to maybe draw that out and talk that through before we go through what the gadgets are, or would you think it's better to go through the gadgets first?
I think it would make sense to talk a bit about the
how it works. Okay, so Inspector Gadget is IG a normal? It makes a lot of people think of Instagram, but is that a normal abbreviation for Inspector Gadget?
No, we wouldn't use it because I think we have a CLI tool called IG as well. So
Okay, so we'll use it. Okay.
But that's we won't use it for the project Inspector Gadget. We won't.
Oh, don't use it.
Yeah.
For the project. Okay, so I'll write it out. So, Inspector Gadget acts as a package manager and orchestrator for eBPF programs. That's cool. Cool.
Cool.
So let's talk about a little more about how that works. So we have, we'll say 3 nodes. I haven't had to depict a kernel on a node before. I'm not sure how I'm going to do that. Okay, I'm a professional lightboarder and I can't make 3. Sometimes I laugh because I'm like 45 and a professional streamer. Okay, so we have our 3 nodes and we have Inspector Gadget pod.
Yes.
I really want to write IG pod. I think there's no way around it.
You can write it as a gadget pod, but I think that's okay.
Okay, I like it. Good compromise. Gadget pod, and it's running as a daemon set.
Yes.
Aha.
And I would say we have a client.
Is the client running us just on wherever?
Yeah, the client could be on a Linux box or Mac OS, but it's like it talks to these pods.
Just one copy.
That's not on the node itself. It could be.
Okay. Can it be on the node, or it's definitely not?
It's definitely not a node. But we have like these different modes of running. So we have something for Kubernetes, but we also have one for Linux host, and then it's different. The client is running like on my laptop, for example, and I'm connecting from there. Yeah, okay, that's the kernel level. Cool.
I figured it out. Yeah. Kernel, and then we have a client.
We have like, you can call it kubectl gadget.
So the client is a CLI only?
Yes.
Okay.
And that client is talking to all these pods.
Okay.
And if you want to run a gadget, you would do something like kubectl gadget run, and that will run the gadget. And what happens when you do that, and maybe we talk a bit about that.
Runs gadgets and schedules.
Yeah. So for
Yeah.
it can, once you run the gadget, I think what happens is that each of the gadget pod will pull the gadget image you're interested in from an OCI registry. Just like for Docker containers, we pull the images from a Docker registry or a container registry.
So it runs the gadget, and then is our final goal to have the gadget running in every in the kernel on
Yes.
every node? Okay.
Yes.
So talks to pods. Okay, runs gadget, and it does this first by instructing the gadget pod to pull the right eBPF
Yes.
program.
The entire OCI image.
Okay.
So for example, this gadget itself is an OCI image and it lives in a registry. So you would give it a name for that OCI image.
Okay. And so I run gadget run, go gadget run. And so now, and then so the client, and what that looks like is the client communicates with each pod and says, hey, we want to run this gadget on in the kernel. And then each pod reaches out to our registry.
Yes.
And says, okay, we're pulling the image, the eBPF program. And
then it will take care of loading that into kernel, and then doing all sort of magic, and then eventually you as a client will start to see data on your terminal once you run it.
Gadget pods pull
gadget image, I would say. Gadget OCI image.
Gadget OCI image.
Loads.
Runs. Okay,
yes. Loads the eBPF programs and then start to collect the data.
Does it collect the data and report it back to the client?
Yes. This is something I think at that point, like I want to talk more about this idea that we have. Like it can report back to a client, but it can also export it to Prometheus, and then you can visualize it. You can visualize it using Grafana as well. So it's more like, it's not just that you can do it in a CLI fashion, but you can run a gadget and then that exports it to Prometheus, and then you can visualize it as well.
So gadget pods, one, pull the gadget OCI image, two, load the eBPF program. eBPF for the win. Woohoo! So now it's running. And then collects the data from the eBPF program, and then with that data, so 3 collects data, and then 4 with that data reports it back to the client or exports it to Prometheus,
Yes.
or both. Yeah.
Yeah. Yes.
Awesome. Look at us go. This is satisfying. Cool.
I think this is kind of overall, like, I think one of the things I want to highlight is that this is what we did on kind of a Kubernetes environment, but we have IGCLI,
Uh-huh.
which can do it on a Linux host. So in that case, you will download a IG CLI, and that can run the gadget on your Linux host directly. So once you would do something like IG run name of the OCI image, and it will pull the image from the registry and run onto your Linux host directly.
Got it.
And once running on the Linux host, you also have the information about the standalone containers. So for example, if you had some Docker containers or some containerd containers, then they are, you can see the enrichment in the events from there.
Awesome. Okay, so now we have a little bit of room left on the board to talk about the gadgets themselves, or is there more that there is to understand?
I think what I wanted to talk about is more like how to build your custom gadgets. So that's one idea.
Uh-huh. I trust you. You're the expert. I believe you should control this more than me.
Yeah. I think what maybe we can talk a bit about the certain use cases that we talk about, but maybe we need to manage. I'm thinking how much space
goes fast, right?
Really, it goes really fast.
It's cool though. Yeah.
Yeah.
I'm happy with what we've talked about. I've learned so much.
I think maybe we can quickly talk about some of the gadgets I told about, like this trace DNS. Maybe we can just list them.
Yeah.
And then from there on, maybe we can talk about how it works under the hood.
Okay. So some gadgets.
Yes.
Trace DNS.
Yes.
Traces DNS.
Yes. That allows. Yes, exactly. It traces DNS, but and then you have this snapshot process, which can actually show you the processes running in different containers. So that's
like a separate one, right?
Yes.
Okay, so I'm just going to list them, I think, instead of trying to say what they are. You can look up what they are if you're curious, and it sounds like they're named pretty in a descriptive way. Snapshot process. What's the reason why you would want to snapshot a process?
For example, you want to see which processes are really running in your containers.
Which processes are really running in your containers?
So for example, that would be something like...
Are your containers doing what you think they're doing?
Exactly.
Which brings up a point where I have written the words Inspektor Gadget on this light board before today when I did an episode with Kubescape. They use Inspektor Gadget under the hood as part of their security stuff. So maybe this is one of the things they use. I don't know.
So we have this gadget called Trace Open.
Trace Open?
Yes, and that can actually look for open files, any file that any container or pod is opening across your cluster. So this can already give you a hint that you can see if there are any files which shouldn't be open are being open, something.
Cool.
And then we have different gadgets like the one I talked about, profile block IO, which allows you to really see histograms on your CLI.
Profile block IO. Shows histograms of what?
of the block IO latency.
Oh, I don't know what block IO is. That's where.
Is basic input output. I think it's how you measure your
Yes.
block devices.
Okay.
And
This
then
is
you have, this is kind of just to give an idea of what different sort of gadgets are there. But I would say that if you are interested to know more or like kind of discover them, you can head to Artifact Hub.
okay.
It's a CNCF project as well. And what there you can do is that we have our own kind there, and you can really filter based on, oh, I want to look for Inspector gadgets, and then really like discover different sort of gadgets there.
So probably you could go to the docs and you find your way to the right artifact hub from there. Would that be a
Yes.
good way? You're checking it out?
Yeah, I think maybe a link.
Cool. Artifacthub.io. Sorry, this isn't. There it is.
Yes.
There
So
it is.
you can go there, and then from there on, we have our own kind there. Like you can select the kind of the package to be Inspector Gadget, and then from there on search for trace open, or I don't know, I want to see open files and DNS, and then it'll pop up the gadget you should use.
Excellent.
So that's kind of for the discoverability for the gadgets.
Okay. Smart.
I think we already touched the point about being able to export it to Prometheus, and yeah, okay, great. One of the small things I want to talk about, one of the feature I want to talk about gadgets is that there is this filtering we have. So once you run a gadget, you can filter by pod and by container or by namespace. So I would say the filtering part.
Does the client do the filtering?
No, it's happening in the eBPF
Okay.
within the kernel. So if I want to see, like for example, let's just say files being opened,
So
really,
is that the WASM program filtering?
No, it's more
Okay.
like it's happening within the kernel. It comes with the BPF.
Okay.
Like what we do with like what our framework provides you, that you can actually really filter stuff. Like it's not like we are collecting everything and giving it to you. If you really want to inspect a single container,
so
it's really, and on that level you can really filter and get events for a specific container only.
okay. It happens on the eBPF. Oh, I'm confused. Yes. Repeat it. Say it again.
So what I'm saying is that, for example, if I want to see, let's just say, certain events for a specific container.
Yeah.
Let's say I want to see what files are being opened by a container, by a process in a container. I will have a filter for it. And that filtering will happen in the eBPF, so like in the kernel space. So it's not like we copy everything to the user space and then filter it at that level. Within the kernel, we're able to filter based on the containers on what information.
And then you're running a specific gadget that's meant to see just that container.
Yes.
Okay. So it's happening so I'm going to put it here. It can filter. It's mandatory. It collects data and it can filter. Does that feel like the right spot?
Filter by pods. I would say filter by pods, namespace, and containers. Yeah.
Awesome.
Yeah.
Maya says they would like to hear about some use cases. What do you think?
Yeah. I think we did cover some with these gadgets, right? Or they
We
meant
covered trace DNS, snapshot process, trace open, which looks for open files, profile block IO, that shows histograms of block IO latency. Do you think this counts as use cases? I had them
I
as separate in my head for some reason.
now I would assume that it's kind of covers the different gadgets and their use cases. Are you meant more like what I would do with this information?
Oh, yeah. Maya says we did it. There's a comment from earlier. But that is a question I have. Like, for one thing, are you likely to use one of these tools? Are you likely to compose several of them? Like, what problems are you feeling in your organization that makes you think to come to one of these solutions?
Okay.
I guess those are two different questions. Yeah.
No, I think I totally get it. I think there's like, for example, if you pick this trace DNS, one of the issues you have is Kubernetes is like a complex, like it's composed of different DNS components. And you have like core DNS pods, you have system D resolver. So you have all different, and you have this upstream DNS server. So you have all these different components, and you want to really debug that system. So what this trace DNS gadget allows you is to really see which component is doing what. So I can filter what core DNS pods are doing. Does that?
Kate's, yes. An example problem, Kate's DNS is hard
Yes.
with many DNS systems at many levels, right?
Yes, exactly. And this gadget actually allows you to really inspect specific systems. Like I can see what's happening to my request by at an application pod level.
Trace DNS gadget solves this.
Yes.
Helps you understand. I guess solves this.
Exactly.
Which
and
one?
if you,
yeah.
Yes, I would say it's like it's hard, and it allows you to kind of really inspect and troubleshoot all the problems. I think the guide we have is try to explain how would you be able to inspect a specific system or a specific level.
Understand and troubleshoot. I'm not going to write
Yes.
both because yeah.
Yes.
Cool. That's helpful.
Cool. Yeah, I think the other thing I would highlight that one of the things we have is that once you have these OCI images, like these gadget images, so for all the one that we officially maintain, we publish them to OCI registry. We also sign them. So there is this aspect of security that we built into them. So you can sign when you publish your images to an OCI registry. For us, we sign it with our private key. So I think this to kind of give an idea that we have security mechanisms in place. So if you want,
Inspektor Gadget. Gadget images. They are, first of all, they're maintained.
yes,
Which I think is important. Then they're discoverable on Artifact Hub.
yes,
And they're signed. And I guess since they're OCI, that means they're compliant with your registry or anything.
yes,
So,
yes.
So that's a good point too.
Yes. So it's like if you already have a process of hosting OCI artifacts in your organization and like having a proxy locally blocking them, you can also use that mechanism. But we also have all the mechanisms in place to help you to make sure that you run the right gadgets secure.
Awesome. Is there anything else we want to add on this point?
No, I think it's
Cool. Is it the people who use Inspector Gadget, are they coming for one thing and then figuring out what other gadgets they can, how do they find their way to Inspector Gadget?
I think it's more driven by the problem you're trying to solve, right? So for example, I think one would be that you want a certain observability data, and then you can start off from specific gadgets and thereon maybe see that it provides you the way to collect some and then see and slowly expand to different gadgets as well. But initially, like for example, if I'm some engineer and who wants to debug troubleshoot something, like I would pick a certain gadget and then see what else could be there step by step based on the use cases.
This is really cool. I just really, among other things, I really like the idea of the package manager and orchestration for eBPF.
Yeah, because I think that's one of the hardest thing to be able to. I think what I want to talk about, maybe what's left we have, is maybe what the framework offers.
Okay.
Like if you are, like for example, want to have like a custom use case, or you want to be able to extend, like for example, we provide this trace DNS gadget, right? And you see that you want to extend it naturally. How do you do that? So that's why we have this entire framework that you are able to modify the eBPF programs, push the images like the OCI artifacts, and run it on your own systems. So that's kind of.
Is it more common to write one from scratch or to modify what the Inspector Gadget?
I think I would say that right now it's more like we are into this phase that we release the image-based gadgets. We bring them out like out of the experimental and stuff like last month. So we're getting there and we're trying to collect the use cases. But it really depends on use case. If you have a problem we don't have any gadget for, you can develop it. But if you have something that's there, then you can build on top of it. So it depends entirely on the use case.
Extends
or create new.
Extend gadgets for your use case. We have a great question too. I've been learning a lot about observability, so maybe I'll try my best to take it. Extend gadgets for your use case and create your own gadgets. BYO. Well, B can be bring as well as build, so that's not.
We have a term for that. We call them image-based gadgets.
Yeah, image-based, build your own gadgets. Build your own. Is that
gadgets.
All right? Build your own gadgets? Okay. Cool. So Dinesh has a good question. How does Inspector Gadget fit in with the OpenTelemetry ecosystem? So as we talk about when we went through the architecture diagram, we're getting all the information through the pods back to the client, and then it can export that data to Prometheus is one of the things. So Prometheus, you're like, wait a minute, that's not OpenTelemetry, but OpenTelemetry can understand Prometheus data. So therefore it can plug into your OpenTelemetry system. Is that correct?
Yeah. Yes. And one of the things I would talk about is that we use I'm trying to find the words to correctly define it, but we have this idea. So Inspector Gadget itself is very modular. So we have once we collect the data, it goes through different pipelines, and then eventually it's kind of like for each of the things I talked about, we have different modular component. We call them operators doing something for it, and we have an operator for hotel. So we have this hotel matrices, which is actually allows you to publish the matrices.
And what level is that operator at?
So what, where does
is it part of the?
Gadget
Actually, let
pod.
me back up and before I ask about that operator. So we said the pods pull gadgets, load the program, collect the data, and they can report that data to Inspector Gadget, or they could report it to Prometheus. At this point,
Yes.
it's the pods. But then, like, whose job it is? You're getting data from all different places. Does Prometheus just receive it as one data stream from all the pods, or is
I,
it care that it's separate, or is
I
that a
think
Prometheus problem? Yeah.
it's a Prometheus problem because they do
Okay.
this because they do the scraping. We just expose that via some
Okay.
endpoint, and then they scrape the data from us. So we just
Okay.
provide this. So we have a way to expose the data that can be scraped off by Prometheus.
Okay. Yeah, that makes got it. And then when you say the OpenTelemetry exporter, where's that happening?
It's happening in the gadget pod.
Okay,
Like
in the
we have gadget pod that where they can then you can export the data there.
Okay, so there you go. You can
Yeah.
OpenTelemetry exporter as part of the gadget pod.
But I think this idea of I'm thinking if we have space on the board to talk about them.
We don't have to write everything down also, yeah. But what do you want to talk about?
I think there's what we have is this Inspector Gadget. There's this modular component we called operators, and they do certain tasks. Like one of the tasks, yeah.
I have a quick question. Would you like me to write operators in our last bit of space, or should I save it for something else?
I think because the thing is that I want to talk about operators, and then there's another concept as well, and then combine
Okay.
that to kind of give an idea how to write your own gadgets.
Okay, got it.
So
So let's
maybe
just talk about it. I'm not going to write it down yet.
yeah
I'll keep it in my pocket.
we discuss if we feel like it can fit in, and then we'll hop to it.
Perfect.
Yeah, I think it's just like this. We have these modular components called operators, and they kind of do different things. So, for example, they'll take care of pulling the images. So we have an operator called OCI that will take care of pulling the images from OCI, and it'll also take care of getting the eBPF programs out of those images and loading them into kernel.
Okay.
And then you have an operator that actually talks to Kube APIs. We call this operator, maybe we can just list the operators and then
And the operators are all happening inside the gadget
gadget
pod.
pod. Yes.
Okay. And is the gadget pod made up entirely of operators, more or less? How to
Yes.
say it uses? Gadgets
Yeah.
pod uses operator.
It's kind of the fundamental in our architecture. That's how we do everything.
Okay. Example
We have
operators.
yes.
Okay.
So we have like an OCI one.
OCI pool.
So it pulls the image and extracts the eBPF programs and runs them. So we can maybe just put the name of them or
Just OCI?
yeah.
All right.
I'm really trying to think.
I enjoy your passion for this stuff. OCI, got it.
And then you have like a Kube manager.
Kube manager.
That actually takes care of really getting all the information about pods and containers from Kube API server and then enriching the events with everything.
It gets them from Kube API server and enriches it.
Like, for example, the events you get from the eBPF, they then need to be enriched with information about.
So yeah, given context of everything else
Yes.
that's happening in the
And-
system at that time.
Yes. And then one other operator you can think of is a filter.
Okay.
This is and that allows you to kind of filter certain events. And then you can put hotel matrix as another operator. So this was just to give an idea that we have these building blocks that work together to compose Inspector Gadget, what it does with the observability data.
Cool.
And It's right now. It's like it's a part of the Inspector Gadget code base, but in future maybe we allow you to write your own operators. So if you, for example, want to uh, uh, export your matrices or export your observability data to custom, like proprietary solutions, you can do that or something like this. So it's just to give an idea that operators are essentially what the data you collect, they process it or do different sort of things with them.
Awesome. And you can, so just like everything, you can kind of customize it for your
Yes.
particular. Yeah.
Yes. And yeah, I think the last thing I would talk about is data sources.
Data sources.
Yes.
Okay.
So because since we're talking a lot about data being collected with eBPF and being processed, the way this data is collected from Linux kernel using eBPF, we have certain abstractions that allows you to, for example, think of if you have a specific use case in mind and you want to write a gadget for it. So, for example, think about it that we have a concept about a data source called tracer, and that will allow you to write eBPF gadgets, which like will trace, which will give you a stream of events, like for example, a file being opened.
Gadgets can use different data sources.
Yes, it's kind of an our own component.
Okay, it's a data source component as part. So now we're talking about the gadget.
Yes, and
Okay.
we have these different data sources, like which you can like call tracer. One of the example is tracer.
For example, tracer gadget.
Yeah, I think we have a great overview of this in the blog post we published. So I'll just maybe put it in the chat.
So in this introduction to gadgets blog post will help you understand that different gadgets use different data sources.
Yes, the reason I'm talking about data sources, maybe we can just put it there if we don't want to devipe into different type of data sources. There is one called map iterator. It's just to that if you come up with your own custom use case and you want to write a gadget, you will pick one of the data source, or because, like for example, if I want to trace certain events, like for example a file being opened or a certain subsystem doing something, I will pick this data source and start to build around it my gadget. So that's why kind of this, maybe we can just say that knowledge of data source helps you to kind of get started into writing.
It's a construct, right? Which is a construct that helps you write write your own gadgets.
Yes.
That makes it easier to write your own gadgets.
Yes. So it's kind of a bit of an abstraction built on top of eBPF, so it allows you to easily reason about your use case and then build gadgets.
Cool. Cool. It's a construct built on top of eBPF. Okay.
Yeah.
Yeah.
Yeah. I think we have. I want to kind of try to summarize the different. Yeah. I'm just thinking, like for example, if you now, like for example, we have a bit of an idea about the operators. So these operators that I talked about, they actually process the data that's being generated the data is coming from these data sources, and this type of data source decide how the data is coming. So that's kind of the basic understanding of how different important components are there, and then you can write your own gadgets. And to really write gadgets, again, I would post some links.
Hello, world.
Yes.
Okay. So to use Inspektor Gadget, you have your gadget pod that's running as a daemon set, if you're using it in Kubernetes.
Yes.
And you have separately, you have a client running an Inspektor Gadget client, so kubectl gadget.
Yes. Yes.
So with this client, you can communicate with the pods, you can tell it to run the gadget. And so the gadget itself, the gadget pod, has lots of different operators. So with the operators, that's with the OCI is how it's able to pull and do whatever, pull the gadget and run the gadget. But it also has other ones, like a gadget that can filter and a gadget that can, operator that can filter and an operator that can export OTel metrics. So regardless, the gadget has been instructed by the client that to run a certain eBPF program, to run a certain gadget. So it's going to pull that gadget, run the gadget, and now we have our eBPF programs running in the kernel space on each pod. And those eBPF programs are collecting data, and then they can they're reporting that data back to the gadget pod, and then from there the gadget pod can either or both. It can report it back to the gadget client, or it can export it to something like Prometheus or OTel metrics if you have that particular operator installed. And that's how that works. Does that? And then the data sources are ways for you, is an abstraction for you to help you write your own eBPF program. So you can be like, eBPF can see all these different data sources, like a file being opened or permissions being changed or whatever.
I think it's a construct within our I would say the helpers are the library we provide when you start to write your own. So this hello world gadget, for example, if you pick that up, you would at some point, like for example, having an understanding of what is a data source will help you to write your own gadgets and stuff like this. So it's kind of, that's what I wanted to say. It's kind of one of the basic ideas I would try to understand, and then use that to kind of write my own gadgets. And to do that, I would go to this hello world example.
Oh, to go to the one that we already posted in the chat. So go to that. Cool.
So if you want to do, and to kind of, if you try to see the overall board, one of the things we kept in this project is very modular, and it's very it's like allows you to build an ecosystem of observability, like build different tools in the observability space. So like we are like being a framework, it allows you to kind of build different observability tools, hook into really low level stuff with eBPF, and then really relate it to Kubernetes. And the whole power is with you. Like we don't hold you for the custom instrument. Like you can get any instrumentation data how you like by writing your own gadgets. And that hopefully will enable to build an ecosystem of observability tools.
That's cool. It's extensible. So if you feel ready, the way I'd like to close this out is I'm going to recap literally everything we've talked about back at you to see how whether the understanding is good. Does that sound good?
Yeah, sounds good.
And are you ready for it now, or is there any more? Any more you'd like to add before we start recapping?
No, I think we covered everything.
I was closing my, making all the board space I could possibly get. So before Inspektor Gadget, there's a big gap between low-level data that just recently became available with eBPF but then being able to relate that data back to Kubernetes containers and pods. So eBPF had this great potential for performance observability, but it hadn't really been harnessed yet. So that's where Inspektor Gadget comes in. It's a set of tools, and each tool is called a gadget, and it's a framework with the goal of kernel level system inspection and data collection on Kubernetes and Linux hosts using eBPF. So we did a recap on what eBPF is, which I love that definition we made, by the way. eBPF is a sandboxed VM in the Linux kernel that allows you to attach to hooks. So for example, in a file being opened, and then once that hook happens, you can do something like observe or manipulate that particular call. And then a gadget itself, which is one of the tools in Inspektor Gadget, it's an OCI image that's composed of layers, and we drew out the layers here, including eBPF programs. That's the one we talked about most. And this gadget can do observability things. We went over some examples later, which I'll get into. But first I want to talk about the gadgets. So the eBPF layer is probably the most important to the story. It's mandatory. It collects data at the kernel level, and it can also filter that data if you want to only know about a certain pod or a certain namespace or a certain container. You can program that into your gadget. There's also metadata, which will have your name and description and output knobs. There's also the WASM program, which we didn't talk about again, but it helps process the data. And then there's BTF Gen, which I'd never heard before today, and that helps make the eBPF portable, which is a big problem. So Inspektor Gadget, this is a really fascinating concept to me, that Inspektor Gadget acts as a package manager and orchestrator of eBPF programs. So that was a problem that hadn't been solved before, is making that eBPF program portable. So that's cool.
Not portable, like more distributable across the nodes.
Distributable. Okay, I like that.
I know. I think the BTF Gen is handling the portability. So that's, of course, is
portable.
Yeah.
Portable. Okay.
Sorry, I stopped your summary.
Oh, it's okay.
Okay, I think we can continue. I confused something.
Yes. So then we drew out how it works. So we have a 3-node Kubernetes cluster. The Inspektor Gadget is running, we have a gadget pod running as a daemon set on each node. We also have the Inspektor Gadget client as a kubectl gadget. And so the client talks to the pods and says, hey, I want to run this particular gadget. So it tells the pods that. And then each of the pods will pull the right gadget from the OCI registry. And then it will run the eBPF program or programs that are in that gadget at the kernel level. And so these eBPF programs will collect the data and then report that data back to the pod. And then the pod can either send it back to the client, or it can also make it available for Prometheus to scrape, or both. They're not mutually exclusive. You can also customize your gadget pods with operators. So some of the operators, like OCI, makes it so they can pull certain images, but you can also filter at the pod level, and you can use a OTel metrics operator to export OTel data if that's what you want to do.
Just to add that, operators are right now built in, but in future we will allow them to be customized.
Okay.
So that was
Nice.
yeah.
Great.
Okay.
And then, so some examples of gadgets are trace DNS. So we got into that. Kubernetes DNS is hard. There are many DNS systems happening at many levels. So trace DNS gives you a picture of how one DNS request moves through the system. There's a snapshot process gadget. There's a trace open gadget that looks for open files. There's a profile block IO gadget that shows histograms of block IO latency. And there are about 15 different gadgets, I believe you said, that Inspektor Gadget maintains. But Inspektor Gadget also provides a framework to build your own. So let's quickly talk first. Inspektor Gadget maintains about 15 of them. We went over some examples. And they're discoverable on Artifact Hub, the one that Inspektor Gadget maintains, the ones that they do. They're signed, so they're secure and verifiable, and they're also OCI artifacts, so you can distribute them with any OCI system you use already for your OCI compliant, probably container images.
Yeah, just to add one thing to that, this discoverability by Artifact Hub is that they allow you to see the official gadgets, but you can also have community-based gadgets there.
There are community gadgets too. That makes sense.
So that's really make it powerful that if I decide to write my custom gadget, publish it, I can make it discoverable on Artifact Hub as well. So that's kind of help us create a community of it.
That's awesome. And then, well, as you mentioned, community gadgets, Inspektor Gadget also provides a way and tries to help you make your own gadgets. Well, first of all, you can take an Inspektor Gadget and customize it for your use case. So you can manipulate one that already exists, or you can build your own completely. And gadgets, there's this idea in Inspektor Gadget of this abstraction called data sources that help you understand what data is available from eBPF and write a gadget around what data exactly you want to observe in your system.
Or how do you want to model a data coming?
Beautiful. Yeah. Cool. Is there anything? Oh, one thing I didn't say is you don't have to use Inspektor Gadget with Kubernetes. You can use it directly on a Linux host, and you can use a CLI called IG-CLI to run gadgets directly.
Just
on Linux
IG.
hosts.
Just
IG.
Yeah.
And it is a CLI.
Yeah.
I'll just put a little space there.
Yeah. It's all in small, but it's this.
Oh, now you're getting picky.
I'm just like.
No, I'm glad we talked about this. I'm teasing you. I want to get it right. So that's everything we talked about today. Data is collected with eBPF. Data is processed with WASM. And that's everything. Is there anything you'd like to add to the summary?
No, I think I would really like. I think we have everything. If you want to get started with your custom use case, you can pick up like the Hello World guide, or you can really try to deep dive into Gadget source code because of this OCI artifact nature. I think we kind of tried to have this idea what containers have, like being shareable, being deployable, being reusable to observability. And I hope really it inspired everyone to kind of build tools around it.
I think this has been a joy to learn about. You can go to Inspektor Gadget website based here. And then you said a good way to get started is that you have a good series of blog posts that help people get started. So go to the blog and look at that to help you get started. And is there anything else to say?
No, I think we covered everything. Thank you so much.
Awesome. Thank you so much. This was really fun. Thanks everyone in chat. Y'all are the best. I appreciate you. And thanks to people who watched the recording. And where should people go if they want to ask questions to you?
I think we are in the Kubernetes Slack.
Kubernetes Slack. Awesome. See you later. Thank you.
Bye.
Thanks, Qasim, for sharing your knowledge.